Hello everyone, this is Vishwesh, and in this video we are going to talk about aptitude skills, moreover introduction and prerequisites of it. We will be having series of videos on aptitude skills, and this is going to be the first video of it. In this video we are going to talk about what is aptitude, then main categories of aptitude, list of topics in aptitude, and the major focus will be on prerequisites. In prerequisites, in detail we will be talking about the maths tables. Those are very necessary for quantitative aptitude, and also some formulae. Now let's talk about what is exactly the aptitude is. Basically, aptitude is the ability in a way of identifying the problem. It is the way of understanding that problem or the situation. It is the way of applying the logic to analyze the problem. It is the way of solving the problem through shortest route, possible shortest route, and way of finding out the solution at the end. Main categories of aptitude are basically three categories are there. Quantitative, as you can see here, quantitative or mathematical, logical or the reasoning, and third one is the verbal ability or English questions. Now basically in these categories, if we are talking about quantitative, then there will be a major focus on calculations, mathematical part. If we are talking about logical, very less focus will be on mathematical part or almost negligible, and as well as very less focus on English part, but maximum major focus will be on logic. And if we are talking about English questions, verbal ability questions, then very negligible part of mathematical and logical will be there, but major focus will be on English, knowledge of English language. So this is how these three categories are. Now let's go through the topics, list of topics. So if you can see here, we have six we can say categories, subcategories again here. Arithmetic, that we already have seen, the first one. Then verbal ability, that we have seen on the last slide, the third one. And these are the part of logical reasoning, logical or reasoning, or in short logical reasoning we can say. And the last one is also a part of quantitative data interpretation. Lots of calculations we have to do in it. So this is how we have these subcategories, and under each subcategory here, as you can see, we have many subtopics. As you can see, in case of aptitude, arithmetic aptitude, quantitative. In case of verbal ability also, we have these many topics: logical reasoning, verbal reasoning, non-verbal reasoning, and data interpretation. So in total, if we count all these topics, these are 110 topics. And as I said earlier, that this is going to be a series of aptitude topics, so we are going to cover all these topics one by one. Now let's go to the next part, prerequisites. As I said earlier, prerequisites are the concepts with which the learner has to be aware of before starting with the main topic. So this is going to be very important as far as the topics are concerned. So in this, we are going to first talk about math tables, and then we will be talking about formulae. So let's start with the math tables. As you can see here, in schools we already have learned these math tables. As you can see, we have math tables of 1 to 10. So the learner who is really interested in aptitude skills, learning aptitude skills, and also wants to crack the exam, he has to somehow memorize the tables 1 to 10 as well as the 11 to 20. As you can see on the screen, 1 to 10 as well as 11 to 20. These tables somehow he has to memorize. The reason behind memorizing is, in case of calculations, if you know the tables very well, the tables of 1 to 10 as well as tables of 11 to 20, the calculations you can do very fast. as quickly as possible, as well as correct answers you will get. There are tables of 21 to 30 also, but according to me 1 to 20 are sufficient as a part of learning. And once you are very well versed with memorizing of 1 to 20 tables, then go for 21 to 30. So 21 to 30 will serve as the additional part of your learning. Now let's go to the next part. The next table is squares 1 to 30. So as you can see here, square of 1, square of 2, square of 3, and so on. Square of 2 is 4, square of 3 is 9, and square of 4 is 16, and so on. So these many squares you need to remember somehow. So if we compare with the multiplication tables as we have seen on the last 3 slides, those are very important as compared to those multiplication tables. Squares are also important, but a little of lower level. Similarly, we have list of cubes or table of cubes. Table of cubes for 1 to 10, as you can see here. So cube of 1 is 1, cube of 2 is 8, cube of 3 is 27, and so on. So if you remember the cubes from 1 to 10, cubes of numbers from 1 to 10, that will be sufficient. Even if you go for 1 to 20 cubes of 1 to 20 numbers, that will be more than sufficient. Okay, let's go to the next part of this mathematical tables. Next table is square roots. So as you can see here, square roots of 1 to 20 numbers. So square root of 1, square root of 2, square root of 3, and so on. Now my suggestion is, obviously we can't remember these many tables, so many tables. So remembering multiplication tables 1 to 20, remembering squares and cubes will be sufficient. Just try to go through these figures. As you can see, square root of 1, square root of 2, just try to remember the range in which these numbers are. That will be sufficient for taking the approximations. Next, in tables we have cube root table. In this we have cube roots of 1 to 10. Here you can see cube root of 1 is 1, cube root of 2 is 1.2599, cube root of 3, cube root of 4, and so on. Again, no need to remember these tables, as since we all are humans, we cannot memorize all the things. So just knowing the range will be sufficient. Going next, we have table of fractions, percentages, and decimals. Now understanding this table is important instead of memorizing and recalling. So fraction 1 or 1 by 1, here you can see fraction 1, or it is also can be called as 1 by 1, is nothing but 100%, and in decimals it is 1.0 or 1.00. Next we have fraction 1 upon 2 or half. It's in terms of percentages it is 50%, and in case of decimals it is 0.5, and so on. Right? Now logic for remembering all these fractions, percentages, and decimals, also even understanding the logic is, if we consider a full circle and if we divide it into 4 parts and so on, these will be the fractions representing that circle. For example, if we consider a circle, let's say this is a circle, and if we don't divide it, if we consider a full circle, then it is known as the first fraction 1, which is 100%. If we are dividing it into 2 parts, it is half, which is 50%, or in decimals it is 0.5. If we are dividing that circle into 3 parts, it is 1 by 3. If we are dividing it into 4 parts, maybe like this, 1, 2, 3, 4, then it is 1 by 4, which is 25%, and so on. So if you have to deal with these fractions, percentages, decimals, somehow you have to remember these fractions by a circle method, considering a full circle and dividing it into number of those required parts. So that will be a better idea. Going further, we have a table of prime numbers. Now prime numbers are basically the numbers which cannot be divided further, by any other number. So if we try to divide these numbers, we will not get a whole number. So this is how prime numbers are. Now in case of prime numbers, the thing is, all these prime numbers will not be in any multiplication table. Initially we have seen the three multiplication tables: 1 to 10, 11 to 20 and 21 to 30. So out of all these numbers, you cannot see a single number in multiplication number. The reason is, these numbers will not have any factors. Since these are prime numbers, these cannot be divided further, as well as these numbers will not have any factors. For example, if we consider 8 has factors like 2 into 2 into 2. But if we consider any prime number, for example 43 don't have any factors. 53 don't have any factors. 107 don't have any factors. So these are the prime numbers. Now importance of these prime numbers is, when you are doing the calculations, and if you come up with some equations like 107 divided by, let's say, 7, or 107 divided by, let's say, 9, some kind of calculation like this. Now if you know that 107 number is a prime number, then you will not waste your time in calculating approximating and solving it further. So this is how importance of prime numbers is. And in case of the topic number series, these are very, very important. As you can see, if in a number series, let me rub this first. In case of number series, if we are talking about the problem, which is like this: 17, then 19, 23, 29, and next number is question mark. In case of number series, if this is the series which consisting of all the prime numbers, then whatever calculation you may do on these numbers to find out the logic, you will not be able to find any logic, since the reason is, prime numbers are placed in a random manner. So these numbers 17, 19, 23, 29 will not have any particular logic. So these are placed very randomly, and that is the reason, if you try to solve this by subtraction method or by any other method, you will not get any answer, and you will again waste your time. So basically, if you remember prime numbers, if you try to memorize these prime numbers, and as soon as you see the series of prime numbers or somewhere in the calculation, you will get alert. That is the importance of these prime numbers. So my suggestion will be, go for memorizing these prime numbers as much as possible. So here I have tried to show prime numbers from 1 to 200, and even if you can remember the prime numbers from 1 to 400 or maybe 500, that will be better. That will be a stronger point. Okay, let's go on the next part. Next table is about alphabets. So in case of alphabets, here we have A, B, C, D and so on up to Z. Just a second. So here we have A, B, C, D up to Z, right? And if we go on numbering, for A it is 1, for B it is 2, for C it is 3 and so on, then we get this table. Now importance of this table is, when you are solving the problems on sequences or maybe series problems, you will be requiring this particular knowledge. To remember these alphabets starting from 1, 2, 3, 4, that is A, B, C, D till Z, the trick is, we can divide these 26 alphabets into two parts. The first part will be 1 to 13 and second part will be 14 to 26. So 1 to 13 we have the starting from A till M. A to M we have 13, 1 to 13 numbers, alphabets, and 14, that is from N, O, P, Q, from 14 to 26 we have another set of alphabets. So A to M, N to Z, that will be the basis of remembering these alphabets. Now let's go on to the next part, the table of symmetry, asymmetry. Now this is very easy concept. As you can see here, symmetrical parts will have axis on which, if we draw that axis, it will be symmetrical along that axis. The object will be symmetrical. In case of asymmetric object, even if you draw any line, horizontal, vertical, inclined, anything, the object will not be symmetrical. Now in case of this first tree shape like a object, if we draw vertical line, then only it is symmetric about that vertical line. If we draw horizontal line, the object is not symmetrical. That is the important part you need to remember. Similarly, here you can see few alphabets like M and P. So M is symmetrical about vertical axis, but it is asymmetric about horizontal axis or maybe inclined axis as well. P is asymmetric about any axis. If you draw any axis, it is asymmetric. Similarly, natural things like a butterfly, a starfish, these are symmetric about particular axis. Here you can see sphere. If we draw a line through center of the sphere, it is always symmetric about that line. A sphere like earth, if we draw a line or a plane through center of the earth, it will be always symmetric. And similarly for other symbols like this, you can check the symmetric and asymmetric concept. Okay. Going further, here is the important slide, area and volume, formulae of area and volume. Now in this, somehow you have to remember these formulae like circle, circumference of the circle, area of the circle. In case of square, we have area as well as perimeter, and rectangle is there, triangle is there, and other things are also there. Now my suggestion while memorizing or remembering these formulae is try to find out some logic behind all these formulae. Example, in case of square, if we consider this square, it has all sides equal. All these sides are always equal for a square, and that's why perimeter is x plus x plus x plus x. So this way, if we add all these sides, we get x plus x plus x plus x, that is 4x, and that is how the formula is. Similarly, in case of rectangle, we have 2x plus y. In case of rectangle, it is somehow like a square itself, but it has two sides different. We can say here it is xx and here it is y and y. So 2x plus 2y gives 2x plus y. 2 we can take common. Similarly, triangle, then sphere, cube, cone, cuboid and cylinder. These are the different areas and volume shapes. Okay. Going further, indices formulae. Now in these indices formulae, these are also very important. Many of the students find it confusing. That's why I tried to include it here. In case of indices, if we consider a raised to m and a raised to n, and if multiplication sign is there, then it goes for addition. Indices, we need to do addition of indices. If it is divided by, for example, a raised to m divided by a raised to n, then indices we need to subtract. A raised to m divided by a raised to n gives a raised to m minus n. In case of a raised to m raised to n, it is multiplication in between indices and so on. Now in case of sixth formula, if you consider this, the formula is a raised to 0 is always equals to 1. So in place of a, we can take any figure. For example, 2. If we consider 2 raised to 0, then it is always equals to 1. If we consider any other figure, for example 11 raised to 0 is also equals to 1, and so on. Now the logic behind this formula is, if you think that how come this could happen, that any figure raised to 0 is always equals to 1, that the logic behind this is the formula second. Okay, now if we consider, let me erase this first. Now we are talking about this formula, sixth formula. If we consider, let's say a raised to 1 minus 1, okay, a raised to 1 minus 1. So by using this second formula, if we split it, it will be a raised to 1 divided by again a raised to 1. So this gives, we can cut a raised to 1, a raised to 1, and the answer comes to be 1. So this is how the logic is, a raised to 0 equals to 1, provided the a should not be 0. Provided a should not be 0. If it becomes 0, then we have 0 upon 0, which is, the answer is indefinite. So this is how you have to understand the different formulae, understand the logic behind those formulae, and that way try to remember those. So at the end, my suggestion will be, try to understand the logic behind every formula, every shape, every concept, and that gives you the knowledge as well as confidence to solve a new problem, new situation. Thank you.